too. I don't know about you guys, but I like snow, so snow, like, the other night was just kind of a teaser for me. 331, it's on the back counter. We should be in that habit. Your Chapter 3 notes are yellow. If you haven't looked at those in a while, you probably weren't able to do your homework. Why am I saying if you haven't looked at these, you probably weren't able to do your homework? On problem 84, it used some words that I don't know what they mean. Problem 84 from last night's homework, and some of you haven't even looked at last night's homework at all. I can guarantee it that some of you haven't looked at this at all. That's not a good habit. You should be doing the homework the day it gets assigned when it's fresh in your brain. But when we see stuff that we don't know what it means, where do we go look? Math notes. Now, I have changed what is written here, but if you went and looked at the actual textbook, the textbook says read the math notes box in this lesson, but I made your life easier. I put all your math notes together in a packet. So if you open your math notes and flip to the kind of like the third page, right? It's the front of the second page. Multiplicative inverses and reciprocals. Hey, Lane, what are you doing, man? Because we're looking at our math notes and looking at where this thing is in our packet of yellow math notes, and it's super obvious that you're not doing that. It's like, what are you doing? So in old homework that you know is late and is not what you should be doing right now. So can you correct your behavior so I don't have to, because it's embarrassing for both of us? In your math notes, it tells you exactly what a multiplicative inverse is. And the synonym for that is reciprocal. But if I was you, what I would maybe write off to the side, that is like a really good memory trick in my brain. Instead of just remembering it as a reciprocal, I remember it in my brain as a refliprical. Because this SIP, the CIP in the middle of that word, kind of sounds like if I said reflip. What you're really doing is taking that fraction and flipping it. That's the multiplicative inverse. It's also called the reciprocal. Math uses lots of words for the same stuff. Right? Minus, negative, opposite, right? Like we've got all these same words for the same stuff. So a reciprocal, you really just flip your fraction. If it's not a fraction, make it a fraction. Right? If it's a mixed number, if it's a whole number that you have to set up, like make into a fraction, make it into a fraction. Why did I have these open? Oh, we're doing this here in just a moment, so you want these notes out. But then on your homework after problem 84, that will also help you down here on 86, which also, if you're using your math notes, this should look a whole lot like what you have in your math notes. So all that to say, use your math notes. If you didn't turn in the homework yesterday, you got lucky and I did not grade because my evening kind of ran out of time last night. So 312, 321, 322, I will probably grade those the next class period, like during 1B, because that class is taking a test. Also, if you have mastery revisions to turn in, turn those in. All right, a rational number. Everybody look at 331 and grab a highlighter. I don't care what color. Now hold up before you get carried away. What I want you to highlight, and I even went slightly too far, at the very beginning of 87, the word a rational number, the root of that word is what? Ratio. A ratio is any comparison of two numbers. So what we're going to add to our math notes right here is that a ratio is like A compared to B, or A over B, or A written out longwise division, all of those are actually the same thing. Again, math is silly. We have lots of things for the same thing. So whether you put a colon between, colon, semicolon, colon? I think it's colon, right? When it's two dots? I'm seriously asking. I'm not sure.
I don't know. IDK. We don't even.
Okay, well, the one with two dots. Okay? I think semicolon has the yeah, because semicolon's like where the story's not finished, right? Fraction bar is division. Division symbol can turn into a fraction bar. So knowing what we just wrote there, I want you to come down to here and turn each of these. Wait, if that's part B, we should probably answer part A first. So wait, what did we just say? What mathematical operation does a fraction represent? Division. So now turn each of those divisions into a fraction. Like write it in fraction form, right? Numerator, denominator, fraction bar between them. We should have ratio highlighted on our paper.
So we're just rewriting all of these is like what we just wrote up on the top.
Ooh, you said just. That's like a neighbor to the E word. But fine, since Emery, you said just, I'm going to call you out. All right, for I, what'd you write?
I wrote 2 8s and
So like 2 over 8?
Yeah.
Okay. Can that be reduced?
yeah.
Yeah.
Equal to 1/4.
So this 2 eighths can not only be represented as a fraction, but it can be represented as different fractions. And we could, of course, represent it as a decimal, but we're not talking about decimals today. Donna, how would I write out the double I part? Yeah, 72 just over top of 5. Ooh, and that, I don't know about this being able to reduce. Well, we can put it back to a mixed, right? So kind of depends on how you think about simplifying. Sometimes this fraction improper is better to work with. Sometimes it's better to like take it back to mixed. So just for the practice, take a moment, try to put this back to a mixed number. Because some of us haven't practiced this in a while.
I just used my multiplication chart.
So we're wondering how many 5s in 72, but really we're going to say how many 5s in 70, and that's going to be 14. So we get 14 and 2/5. We still got to keep that denominator that we had, because that's the size of portions that we were working with. And triple I here, let's just go class answer. What would we write? 51 over 94. Now wait, read C for a moment, and I want to know if you guys have heard about this before. Read part C. Anyone got any thoughts about that? Lane?
Maybe because, like, if you have, like, for example, a pizza, right? And you cut it into 4 pieces, you're taking the whole of that pizza and dividing by 4, so you have 4, right? But, like, if you have 0 as the denominator, whatever above would just be a whole.
So, if I order a pizza, and for real, we just did on Halloween. I order a pizza. I don't share with my wife. This is, I know, I'm smarter than that. This is one pizza divided by how many? 1. Well, the pizza is divided, but if I talk pizza per person, like, because division is to split up. Who am I splitting this pizza up with?
One.
Nobody else, so just me, right? Pizza divided by me, right? Divided by 1. If I share with my wife, and we both get an equal amount, oh crap, I cut that other one up.
You guys both got an equal amount. She get all of it and you get none.
So I've got my pizza. Right? I split up, divide with my wife, and we each get a half. But then if more friends show up, we need to split up again. Right? But I have that pizza, and I divide by 0. So with me was division by 1. With my wife was division by 2. With my friends was division by like 4. Donna?
Because like if the denominator is 0, well like that number on top divided by 0 equals 0.
It does not equal 0.
I mean, this is one whole.
When 0 divided by 0 is right now. Okay, we're gonna try that.
You could
Ready? Siri, what's 0 divided by 0?
Imagine that you have 0 cookies and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad that you have no friends.
Oh! Shade, Siri! So it doesn't work quite like that anymore, and I don't have an iPhone anymore. But, guys, if you think about division by 0, so let's imagine I place an order for 5 pizzas, right, which is not that crazy. Divided by 0, guys, that is 5 pizzas with nobody to eat them. So what does every person get? But no, it's not nothing because there are no people. Okay, right now, how many pizzas am I ordering? 0. No, like right now, physically, in this moment, how many pizzas am I ordering? 0. So if we set up 0 divided by, there's like 18 of you guys, we'll just say 20, we'll share with some teachers. 0 divided by 20. I order 0 pizzas, I split them up to 20 people. How much do each of us get? 0. But if I order 5 pizzas and then all of us cease to exist, well, first off, we got bigger problems than pizza. Like, where is Thanos and what did he do to make us cease to exist? But like, guys, this in math is impossible. It literally breaks math. If you type it in your calculator, it gets mad. This is what we call undefined. And you could write that in your graph paper if you want, or off to the side of this right here. Division by 0 is what we call undefined. It literally is not possible.
Wait, can we
But
ask?
yeah, that's different. 0 on the bottom, denominator of 0.
Wait, can I ask Siri?
No, because your watch shouldn't be connected to your phone, because then essentially you're carrying your phone around.
Well, I don't have a phone.
Well, we're not going to spend time doing that right now because the answer was not the same the last time we tried. And I got a lesson to teach. All right, pizza. We did this. Oh, yeah, I put this here so I could write up on the board. But, hey, whatever. Graph paper. Before we get to the pizza. Graph paper. Did I have space from yesterday? Yeah, I still had some. Well, actually, the last graph paper that I had was our decimal multiplications. So now I'm just going to draw a line and do, fractions or, what we're dealing with today is rationals. And it's actually division. I'm going to write a fraction up here, and I want you to try to write it in as many other ways as possible, but you still have to use the 2 and the 3. I want you to try to write this in as many other ways as possible. But, I don't mean, 4, 6, 8, 12. It's I don't mean just keep multiplying up. We got to still use the 2 and the 3. And I haven't said this out loud yet on purpose, because I want you guys to talk to your teammates. Take a minute or two. We won't take too long on this, but try to write this in more ways. Yes, has to be a fraction. We're definitely not going to decimals. Come on. 2/3 as a decimal, it never stops. It's 0.6 repeating forever. You don't need a mixed number because this is a proper fraction.
Wait, can we write it as a different fraction?
Well, that's not an equation. That's an expression. That's barely an expression. It's really just a value. So hold on, Lane, ask that louder.
So we can't write it as like -2 divided by 3 and how we did it in our paper.
No, wait, why not? Why are you saying we can't?
Because I thought you said we had to write it as a fraction.
Well, I just said you still need to do, well, so wait, -2 divided by 3. When you said what you said, this is what I thought.
No,
Now, you might have meant this,
yeah, that's not net.
but is this still -2 divided by 3?
Yeah.
Because didn't we just talk about that a fraction is division? So, aren't these identical to each other, really? Guys, this is -2/3, right? Or the opposite of 2/3. But the negative up front is not great for when we do work with it. So as Lane said, we could put the negative on top and make it -2 divided by 3. That's the same. Anyone got another idea of what else we can do that is the same? We had the fraction, or we had the negative in front. We put the negative on top. Put it on the bottom. 2 divided by -3. So you can write down whatever else you want here, but what this is trying to show you is where we put the negative in a fraction doesn't matter.
Yeah.
It's best on top. But mathematically speaking, these are all equivalent. Now, are they all equally as good? Not in my opinion. But you can have your own opinions as you start to get deeper into math. The negative up front is really dangerously close to just looking like it's part of the fraction bar. Right? That really quickly, especially if you're printing stuff out, looks like it's the fraction bar. The negative on top, it's the first thing I think about. Negative on bottom, it's still equal, but it's not the first thing I think about. This, you see more mistakes. When people put the negative on bottom, you just see more mistakes. All right, I want to talk about my leftover pizza. Now, unfortunately, we did not have any leftover pizza. So we get, well, okay, in reality, I didn't have any leftovers because, I'm hungry. But what we're going to solve here on our graph paper is to help Hugh, Madison, and Ramona. They've got 1 whole pizza and 3/8 left, right? So up on the board, if we want to visualize this differently. So here's what we got, right? All these slices, but if you're putting leftover pizza away, you put them together, right? You put all your slices into one box.
Oh yeah.
So if I put my slices together, there's my 1 pizza, right? And here's my extra 3 leftover slices. So what we're going to write on our graph paper for what we have, 1 and 3, because the pizzas are cut into 8 slices, that's what tells me I should use 8 to talk about each slice. You going to write this down or just stare at me?
Are we gonna write more?
Safe. You going to write this down or just stare at me? Yeah, like when I literally said what we're going to write on our graph paper. Do you need a front row seat to be able to hear me better? Because we got one open. If you can't operate back there, we can move you up here. Yeah, it's your choice. You either do what you're supposed to back there or we move you. We're going to split that up into leftovers of 3/4. I'm going to give you probably 90 seconds to chat with your teammate about how you think we can do this. You don't necessarily have to write anything else on your paper yet, but you can. Start talking with each other about how can we do this. It's what we have. We're going to divide into what we want.
Are we gonna write any more rational decision?
Yeah, that's where this is probably, if you're writing this on your graph paper, like I asked you to, like I was just making Safe do, it's probably going under that rational division section. So, like, I'm going to go ahead and write this down.
See, I didn't know if I should like.
But
section
hurry
them
back
up.
because this is like the meat of the lesson. Talk to each other. You're in a group. You didn't say use a calculator. We were talking to each other. We didn't say use a calculator. All right, anyone got ideas? If people are reaching for calculators, we should probably like, because we need to think on our own. Remember, we can't just trust calculators. Lane, thoughts? No. Well, I mean, depends on what you're talking about, but mathematically 4 is half of 8, but when we're talking about a pizza, I think a fourth is bigger than an eighth. So I'm a little confused about what you're saying.
So, then you gotta multiply the 3/4 times 2.
What do you mean?
Oh,
Because, like, here's a fourth of the pizza. So you're saying we want to talk about the fourths as... What are you essentially doing? You're going to make common...
I'm gonna make a common denominator.
Yo, so exactly what Lane just said. We might not need common denominators when it comes to doing multiplication division. You're totally zoned in on whatever it is that you're doing, not what we're doing. But if we want to make better sense of what we're doing, common denominators will help because then we're looking at the slices of pizza as slices of pizza. So let's take this, and if we're going to make common denominators, we might as well make the mixed number improper. Because I spent a lot of time trying to make sure that this is a good visual. We take our 1 times 8 because this pizza has 8 slices.
Oh my god.
Plus 3 more because we have 3 extra, and we actually have 11 slices left over. The 3/4 that my friend said, yeah, box us up some leftovers, give us 3/4. They each actually want how many slices?
6, 8.
You greedy people. You're going to take 6 slices each? Okay, well, how many leftover boxes am I going to be able to do that? Well, really, now that we have common denominators, and you could be writing this down, or if you're choosing not to, that's a choice you have to live with. Now that we have common denominators, what we're really doing is 11 divided by 6. Saying how many groups of 6 slices? So guys, if I come over here, to this 3/4 we turned into 6/8. We turned this into 11/8.
Why did you take your boot?
Hey, Miss Leslie.
So instead of doing nothing, she decided to completely disrupt my class. So it's just funny. Like, she wanted to make sure she wasn't bothering us, but yet all of you... We're really doing 11 divided by 6. So, how many groups of 6? Well, there's a group of 6, right? Can I make another group of 6? No! So what we did I make one group of 6?
Yes.
How close am I to making the next one?
Really close. Really close.
How much do we have?
5, 8.
5. I want 6. So what we really have,
Wait, are you right there, buddy? You're behind your chair.
guys, this becomes
I was really excited.
1 and 5 6.
Let's go.
Stop.
Oh.
Wait, fall off his chair.
I'm really excited because I got it right.
Great. Now let's practice doing it more than just once, because you can get things right by accident.
No, I'm crazy like that.
Pick up your pencil.
Yes.
So, why does this happen? Well, Madison and Hugh and those friends that want to take all my pizza home, they both did it 3 different ways. Ramona drew a number line.
Oh.
She said, all right, 1 3/8, and then, okay, I want to group up my leftovers of 6/8. Guys, I got some people just like drawing and totally off topic. This is one of the hardest things I'm going to ask you to do this year. Division with fractions is really complicated. 1 3/8, if we group into actual 6/8, because that's what they want to take home, I get one of my groups, and then I'm close to making the next group, but what this actually has is only 5 out of the 6 that I was trying to make. So Ramona says her answer is 1 5/6, because we're not now talking about eighths, because the groups I wanted to make were 6 slices each. So Madison sets up pretty much what we did, I think. She ended up doing 11 divided by 6. What's 11 divided by 6? 1 5/6. Hugh takes the crazy complicated way. Hugh uses a giant one
That is a giant one.
and says if what we have is actually 11/8 divided by 3/4, which, guys, is what we had over there, 11/8 divided by 3/4, which we made 6/8. But Hugh says, oh, well, division by 3/4, if I multiply by the reciprocal, so what's the reciprocal of 3/4? 4/3. You multiply by that on top and bottom. This feels kind of complicated, but actually what Hugh did is real simple. You're getting a different seat tomorrow. Nowhere close to winning. You're trying to kick him from under the table. It's obvious you're not that good at being sneaky. Stop what you're doing.
Because he's trying to like push my team back.
And this is why you two cannot sit anywhere near each other for the rest of November.
Alright.
You must be a table apart. I'm probably just going to assign you guys seats.
Okay.
It's really frustrating that the 17 of us in here have to wait based off your immaturity. If you don't want to do math, if you can't do this, just leave. There's 9 minutes left. Just go to the office. That or fix your behavior. Are you?
Yeah.
You got to do more than just say it. You can't just talk the talk. You got to walk the walk, man. So what Hugh actually did is keep, change, flip, which some of us have seen before. So let's set this back up. But let's, instead of taking this division and just dividing it, keep, change, flip. If you have, well, let's just ask this question. Who has no idea what keep, change, flip is? Like, you've never heard of it. You don't know what it, guys, you got to be honest here. Like, for real. Who's never heard of keep, change, flip? This might be a really good thing if all of us have actually seen it previously. Did I put that in your math notes? Somebody check your notes, because I see some of you still have it out. Yeah, for keep, change, flip.
I can't forget it.
Yeah, you put it.
Luke,
You put kitchen.
So, if this is still complicated for you after class, it's in your math notes. Page 4, it looks like it's under fraction division. It's under fraction division. So check it. Here's where keep, change, flip with common denominators is like a magic bullet. Like vampires, right? Magic bullets, whatever.
whoa, bro.
Check it. Why do we keep, change, flip? It's to turn division into multiplication, because we said they're essentially the same operation. But to do that, yeah, I was worried I got too much going on with my computer. If we're going to change this into multiplication, we can't just do that willy-nilly. Like, it's like when we change subtraction into addition. Right? We still have that minus that we got to put somewhere. So what happens here is instead of, like, I can just put that minus somewhere, to deal with this, we flip the fraction that comes after, Because essentially multiplication is the flipped operation of division. So how do we fix that we just messed with this? We flip the thing that comes after it. So we keep the first fraction, we change division to multiplication, we then flip, and now that we had common denominators, well, now they're not both denominators. What happens when you have 8 over 8? It's 1.
It's what? It's a whole.
And this is 11 over 6, which is already what we knew, but now we can use this with any fraction division problem. Any. So guys, more realistically, like, let's walk through again. More realistically than doing this, well, actually, so here's keep, change, flip, just showing again. So here, for anyone wondering, like, wait, how did we get there? Unclick. Okay, there we go. 1 3/8, we made improper. 3/4, we made into 6/8. Good on that. Any questions on that? We then keep the first fraction, change the division, and flip the second fraction. That then becomes 11/8 times 8 over 6, and the 8 on top and bottom cancel with each other, because 8 over 8 is 1.
Why is there 1 next to
Because when they cancel out with each other, they become 1s.
How do they cancel on each other?
Because what's 8 divided by 8?
1.
So here, I love that you're still asking that question, like, because it shows you've got the confidence to say you still haven't explained it well enough. Which please always do that, because I don't always explain things well enough. If we don't cancel out the 8s, because I know some of us are getting confused by that. If we don't cancel, the other options do the math. What's 11 times 8? What's 8 times 6? 48.
And then you just divide.
And this
Simplify.
will simplify down to 11 over 6.
Oh, that's why you do that.
Let's do this again with the more realistic problem. I normally only take leftovers of 3 slices, not 3/4 of the pizza, but 3/8 of the pizza. Okay, so if I take my 1 3/8 and now divide it by 3/8 instead of 3/4, let's put this on your graph paper. 1 3/8 divided by 3/8, because that's more normal for what leftovers I'm going to bring to school.
Were you like on your pizza, Mr. Hudson?
Because pizzas make sense to talk about fractions, because pretty much no one cuts pizzas into 10 slices. Then we could use decimals if we use 10 slices. So we make this 11/8 divided by 3/8, because I'm not as hungry as my friends were. When I do keep, change, flip, 11/8 times 8 over 3, or really this becomes 11 divided by 3 if I cancel out the 8s. And how do I visualize taking those 11 slices and splitting them up into leftover containers, each having 3 slices? We do it. And that's why our answer becomes 3 and what?
Wait, I'm confused.
Say more.
So I did keep, change, flip. So like I kept 11/8, and then I changed it to times, and then I flipped 3/8 to 8/3.
Yeah.
But why did you get 11/3?
Because if I write out 88 over 24, it then would reduce to 11/3 because the 8 on top and the 8 on bottom cancel. Let's do one that doesn't cancel.
Okay.
2 1/4. Actually, I made this one cancel also. On your paper, look at 91. Let's start by making this improper. And since it's negative, where's the better place to put the negative?
On top.
on top, so negative 2 times 8, 16, plus 1, 17. Now we're going to keep change flip.
KFC. Get it? Keep change flip. Kentucky Fried Chicken. But no.
Hey, so considering that your confusion is why we're slowing down and going over this, maybe just stay focused on what we're doing instead of letting your brain wander. This does not cancel out. There's no 8 on top, 8 on bottom, so how do we multiply fractions? Straight through the top, straight through the bottom. Ooh, I would break this up. Do 3 times 10, then 3 times 7. What's 3 times 7?
14.
Close.
Wait, no, 21.
So we're going to get 51. Make sure to bring that negative.
Equals. Ta-da.
That's our answer. And then we can reduce it back to a mixed number if we want. Try B. Don't look up at the screen unless you want to see what I'm doing, but try B on your own. Ooh, negative divided by negative? What happens when we have 2 negatives? No, that's when you have minus a negative. Please quit with the memorized rules. What is the opposite of a negative?
Positive.
So this becomes positive, not addition. It's going to become positive. When you keep change flip, I'm just going to go ahead and drop the negatives when we keep change flip. So this will be 7 fourths times 5 over 2. You should get 35 over 8. And that is all the time we have today. Try your practice tonight. Do what you can. Bring questions. Quit putting things off. I know the habits that some of you guys are in, and it's really not serving you well.
So I have a question. Instead of making students just have a whole bunch of graph paper, why not just have like a graph paper math book?
I mean, you can. You can get graph paper like binders. Or, like notebooks, like spiral notebooks or
But why
whatever.
did you put that on a list when you were first doing it? Why not do
Do
that?
you want to carry around a whole notebook full of blank graph paper, or would you rather just grab graph paper as you use it?
Grab. Book. What?
Then I have notebooks back there. You can have one if you want.
I've already started.
Well,
Really?
I know that it's part of your plan and everything, but like you were totally not focused on what you were doing. You know what I mean? So like you were letting yourself totally zone somewhere else. Like, and that's a you gotta control it sort of thing, right? Because otherwise, if those are helping block out noise and that lets you zone out completely, that's a problem, right? Like it is a problem. If you are completely zoned out and not listening to the teacher, it's a problem. So let's keep it from being a problem, right? Which is going to take self-control. It's all right, I get it. Like the weather's changing, stuff's getting cold.